My best friend said, like, well, okay, do you want to make a PhD in Spain or do you want to become a scientist? And I said, no, I want to become a scientist. And then he said, then pack and go.
I'm doing a series of podcasts on women in AI, and I wanted to speak to some of the inspirational engineers and researchers that we've got at InstaDeep. And thank you for being the first volunteer.
Well, thanks to you for calling. And let's see how it goes, if I'm up to the task.
I'm sure you will be. Okay, yeah, so firstly, AI is one of these terms that we use to mean a lot of different things, and I think it doesn't really have a fixed definition. So where do you fit into this AI world?
Well, that's a great question. I think that some days I feel that I am running in front of AI because I am an expert on classic methods and physics methods that all the engineers are trying to create models that can, let's say, replace them. So I play both at the forefront. I go at the, let's say, leading the race for now. But okay. I help actually to make these models better and how to actually train them and where can we actually leverage them to improve the drug discovery process. So I've joined quite recently, actually August last year. I'm a senior computational biologist at InstaDeep. And I joined after a long academic life. I did my bachelor in physics, and I always have a thing for biology. Like I enjoy math and algorithms, but to me, applying it to life and to proteins and to understand better disease and why things happen at the molecular level was what really caught my attention since I was in high school. Yeah, so for example, where I do my, let's say, bread and butter is to create movies of molecules wiggling and jiggling. I create the systems of my proteins, ideally in the more realistic environment that I can afford, because as you can explain, you have millions of atoms, so the computation grows exponentially. And so there is a trade-off in between accuracy in the representation of my system and actually how much can I simulate. I think there's a book about physics from Carlo Rovelli that explains it very well. When you see a glass of water, you are seeing that. If you zoom in, you will see like just the tiny molecules of water there. That is what I can simulate. But the experimentalist is looking at the glass. You know,
that's a really good image for explaining the concept, I think. So yeah, thank you for that. So you're trying to get the right balance between how much you zoom in versus getting the overall behavior of glass of water in this case, or very complex molecular systems in your case.
Exactly. Yeah. Water, it's still a hard example to simulate, even though it's just a tiny molecule, extremely important for life, but we are still working on it.
Yeah, and I guess you're just adding even more complications when that water is in a cell and there's cell walls and all that kind of thing. I'm just going from my memory of high school now because I haven't done biology since then. But
yeah, but it's a fun puzzle, let's say.
Yeah, sounds like it. And every time I hear you speak about it, you can see that you're really passionate about the subject, and that's always nice to see and nice to hear. So maybe I'll come back to you mentioned that you did a PhD and spent some time in academia doing postdoctoral positions before deciding to make the jump to industry. I know that there may be many people out there doing PhDs at the moment, or maybe they've even started doing postdocs, and they might be questioning whether they should be staying in academia or make the move. Was it a difficult transition for you, and what motivated you to make the jump?
Well, I think that I had a lot of fun at PhD because I was extremely lucky and I got to travel a lot, to be really independent in my research. And it was fun. It was 3 years, really, really intense, but 3 years. But then postdoc, it's, let's say, it's a marathon if you really want to make it to professorship. There are always exceptions, but the norm is that you will have to do like a number of postdocs and changes of cities and countries. And I think that for me, it arrived a point in which I wanted to put some roots, and I didn't want to be like jumping places. But also, most importantly, I think that my generation has the opportunity to work on R&D, on research in the industry with incredible resources. Like if I were to apply to have the computational resources that I have here at InstaDeep in a grant, like I would dream about it. Like it's a total different game. So, for example, I can finally address some complex systems that before I couldn't do it, or test some hypotheses that I had, or some methods that before I couldn't collect enough data points because I couldn't run it. While here I can. And I think that industry gives you some sort of continuity and allows you to work in a problem maybe for a longer time without less interruptions. And I think that's my hypothesis. I'm 6 months in.
Cool. So I think another thing I wanted to ask you about was in a previous conversation that we had, you mentioned that you were involved in the UN Women and Girls in STEM initiative.
Yes. So
I think that was during your time in academia.
Yeah, while I was doing PhD in Italy, they had this initiative that for the Day of Women and Girls in Science, it's STEM, we would do a masterclass. So we would invite high school girls to the university, and then different women academics will have... actually, I gave them computers to make them simulations. Maybe it was a bit overwhelming, but I think it speaks about representation. There is someone that you can relate with, that it looks like you, speaks like you, and feels like you. And you get to do the same work, and they were really curious. It's I have always have great experiences when working with kids or like, let's say, the big public.
Yeah, I think you sometimes get more interesting questions as someone who's completely outside of the field, because you're like, this is a different set of eyes on a problem.
Yeah, it's really encouraging. They are super curious, and they really like the science and brainstorming with you. It's really fun.
That's really cool. And it's nice to have scientists like you going and speaking, and it keeps that curiosity alive, and being able to have a role model to know that, you can have that curiosity as a job is a really nice thing.
If you look at my computer, it looks like I'm playing video games all day. But no, I'm actually looking at product.
Yeah, honestly, I'm working. And so if you were to speak to some high school students right now, or people who are in university, and they're like, okay, well, what are the practical steps I need to do to be able to succeed in the same way as Silvia has? What advice would you give them?
Well, apart from the obvious of signing at the university and studying some of the sciences, then I think it's very important to speak up and to knock on doors. Like, for example, when I was applying for PhD in Spain, I didn't get any. And then I got a very theory. I got an opportunity somewhere else, but because I knocked on that door, like my best friend said, like, well, okay, do you want to make a PhD in Spain, or do you want to become a scientist? And I said, no, I want to become a scientist. And then he said, then pack and go.
Okay.
because you need to chase your opportunities and you need to speak up and go to people. Like I've been in conferences and say, okay, there is this professor that I want to speak with them because I read this article and I really like it. And you have to go there and say, okay, do you have 5 minutes for me? And speak with them. If they don't have 5 minutes for you, well, that's a good indication that maybe you don't want to talk with them. Actually, but the vast majority, they will have 5 minutes for you and to listen to you. And they will be actually really flattered by you going and asking questions about the work. Talking about women in AI and women in STEM, let's say, like you also study physics, so I'm curious, like, were you the only girl in the class too? Because that happened to be a lot while studying.
Yeah, so for my undergraduate, I actually did engineering, and I wasn't the only girl, but we definitely weren't the majority. And then for my doctorate, I suppose I went more into physics by modeling neutrons in nuclear reactors. And definitely when I started, I was the only girl in that lab. But yeah, I guess when you start off doing engineering, you're kind of used to there not being that many women around. And I think what made me the odd one out in that lab was being an engineer and not a physicist. So there was
you were a double outsider, okay?
Yeah, double outsider. There was one of the professors that called me the oil and rag brigade because I was the engineer. But I think it's something that maybe was a bit weird at the beginning, being the only girl, but over time more and more women joined the lab. And I think it's something that's definitely improved over time. So when I was in high school and saying that I was going to study engineering at university, you'd get the kind of like, oh, okay. As in, wasn't expecting that. Whereas I think now that reaction would happen less often, I think. Okay, well, I think we could carry on speaking for ages, but unfortunately, we should probably stop there, and we've both got work and experiments to get on with. So it's been really great speaking to you, learning more about you and your experiences, and we can speak next time I'm in London or next time you're in Paris.
Thank you very much, and I hope to speak to you soon.
Thank you. Bye.
Bye-bye.